On Proxima B, life might not exist under a blue sky, but beneath thick clouds, salty oceans, and a world where one side never sees daylight. Simulations suggest that if this planet has a thick atmosphere and a strong magnetic field, heat could move from its burning day side into its frozen night side, keeping regions of liquid water alive in places that never receive sunlight. And if life can survive in Earth's Dead Sea, then maybe, under the angry glare of a red dwarf star, Proxima B is not dead at all. Have you ever wondered, when you look up at the stars on a clear night, whether something out there might be looking back? Because on the surface, the galaxy feels eerily silent. So far, we've detected no confirmed signs of life, but the search has only just begun. Even within our own solar system, scientists now believe life could have independently emerged in places like Jupiter's icy moon Europa or Saturn's mysterious moon Titan. So the real question is, could there be a world beyond our solar system where life has truly taken hold? It turns out that world might be much closer than we ever imagined. A planet similar in size to Earth, orbiting the closest star to our Sun, Proxima Centauri. And despite being constantly bombarded by intense radiation from its star, this nearby world could still be one of the most promising places to search for alien life. If you're curious about what life beyond Earth might really look like, make sure to subscribe and stay with me, because what we're about to explore might completely change how you think about life itself. The star Proxima Centauri is unusual by any measure. It's part of a triple star system, where the two main stars, Alpha Centauri A and B, are both similar in size to our Sun and orbit each other closely. But Proxima Centauri is very different. It's a small, low-mass red dwarf star, much cooler and far dimmer, so faint that it can only be seen with powerful telescopes. And yet, it is the closest star to us, sitting just about 4.2 light-years away. Around this faint star, astronomers have identified at least 3 exoplanets. 2 have been confirmed, and one of them lies within what we call the habitable zone, the region where temperatures could allow liquid water to exist. This planet is known as Proxima B. Discovered in 2016, it immediately captured global attention, not just because of its location, but because it is roughly Earth-sized, and most likely a rocky world. At first, there was real hope. Maybe this planet had an atmosphere like Earth, the same chemical ingredients, maybe even oceans, and life on its surface. But as more data came in, that optimism began to fade. Because despite these similarities, Proxima B is on a very different path. Proxima Centauri is only about 14% the size of our Sun, and much cooler. But that also means its habitable zone sits extremely close to the star. So close, in fact, that Proxima B orbits more than 20 times closer to its star than Earth does to the Sun. A full year there lasts just 11.2 Earth days. You might expect a smaller star to be calmer, but the reality is the opposite. Red dwarf stars are far more violent. Their energy processes occur closer to the surface, making them highly unstable. The result: powerful magnetic fields and frequent, massive stellar flares that release intense bursts of high-energy radiation into the surrounding system. And because Proxima B orbits so close, it is likely being constantly exposed to space weather far more extreme than anything we experience on Earth. This is not just a harsh environment. It's a world under constant assault. The planet is also most likely tidally locked, one side permanently facing the star, the other locked in eternal darkness. On one side, endless daylight and radiation. On the other, a frozen night that never sees the star at all. The star-facing side would be relentlessly exposed to radiation and possibly violent flares. In fact, in 2021, Proxima Centauri unleashed a flare around 100 times more powerful than anything ever recorded in our solar system, a reminder of just how extreme this environment really is. These flares are not rare events. They may happen repeatedly over time, slowly wearing down the planet's defenses. Some scientists believe these intense outbursts could gradually strip away the planet's atmosphere, if it even has one, and completely eliminate any water on its surface. So even though Proxima B sits within the so-called habitable zone, its extremely close orbit around a volatile star means it might not be habitable at all. To survive, the planet would need a very thick atmosphere and a powerful magnetic field strong enough to withstand radiation levels up to 500 times more intense than what we experience on Earth. On the surface, this kind of environment would strip atmospheres, evaporate oceans, and destroy DNA on any nearby world. But here's where things begin to change. Because despite everything we've just described, Proxima B might not be a dead world after all. New climate models suggest something far more surprising. Using advanced supercomputer simulations, scientists have modeled different environmental scenarios to understand how such a planet might behave. These three-dimensional models reveal how atmosphere, temperature, and energy flows interact under extreme conditions. And what they found was unexpected. Even with one side locked in constant daylight and exposed to intense radiation, the planet could still maintain habitable regions under the right conditions. If Proxima B has an atmosphere similar to Earth's, along with a strong magnetic field, it could deflect much of the incoming radiation. In that case, the planet might be covered by a vast ocean, stretching from the day side into the eternal night. Seen from space, it might look like a giant eye, staring directly into its star, a world unlike anything we've ever seen. Imagine standing at the edge of that ocean, a permanent twilight stretching across the horizon. Violent storms where scorching heat collides with endless cold. A planet where weather is not seasonal, but eternal. But Proxima B is not the only place we might find life. And more importantly, it may force us to rethink what life actually is. How much of the planet this ocean covers would depend on one key factor: salt. Higher salt levels lower the freezing point of water, allowing the ocean to extend deeper into colder regions. And according to these simulations, even with high salinity, a thick atmosphere and a strong magnetic field could still allow a global ocean to exist. And if the right chemical ingredients are present, then Proxima B could, in theory, support life. On Earth, we already see examples of this in places like the Dead Sea, where salt concentrations exceed 30%, microbial life still finds a way to survive. Which means life on Proxima B may not need Earth-like conditions at all. In this scenario, thick clouds on the star-facing side could act like a massive shield, reflecting a significant portion of incoming radiation. Combined with atmospheric and ocean circulation, heat could be redistributed across the planet, preventing the atmosphere from collapsing and allowing liquid water to persist even in regions that never see light. Of course, these are still models. They don't confirm whether Proxima B actually has an atmosphere, or any water at all. But if the planet formed with enough water in the beginning, there is a real possibility that some of it still remains today. It's also possible that Proxima B once orbited farther from its star before slowly moving inward. A journey that may have shielded it from the most violent flares during its early history, giving life a chance to begin. If life does exist there, it would evolve under conditions completely unlike Earth, not powered by stable sunlight, but possibly driven by chemistry, heat, and survival under constant radiation. No forests, no animals as we know them, but something else, something adapted to endure. Under those alien skies, the surface could be a patchwork of extremes: frozen wastelands, jagged mountains, endless deserts, and oceans stretching from horizon to horizon, a world shaped not by balance, but by contrast. And if a world like this can support life, then it changes everything. Because red dwarf stars are the most common type of star in the Milky Way. In fact, Around 20 out of the 30 closest stars to Earth are red dwarfs, which means planets like Proxima B may not be rare at all. In that case, life in the universe might not be rare. It might simply be unfamiliar, and perhaps we are the unusual ones. As of now, Proxima B has never been directly imaged. Everything we know comes from indirect measurements, leaving plenty of room for speculation. But that is about to change. The James Webb Space Telescope may soon be able to detect signs of an atmosphere. And there are even plans to send tiny, laser-driven probes toward the Proxima Centauri system, possibly arriving by the year 2075, a journey that would take humans thousands of years. But perhaps the most exciting breakthrough will come from the ground. A new observatory, known as the Giant Magellan Telescope, is expected to achieve a resolution 4 times greater than current space telescopes. It is still under construction, with first light expected around the year 2029. And when it does, we may finally see Proxima B not as a distant signal, but as a real world, perhaps even capturing its motion around its star and analyzing its atmosphere for signs of life. So the future is becoming incredibly exciting when it comes to our closest exoplanet neighbor within the next few years. We may finally begin to answer the question and move beyond speculation. Is Proxima B truly a world capable of supporting life, or just a barren, sterile rock drifting in the dark? And when that moment comes, it may not just change what we know, it may change how we see our place in the universe. Because if life can exist there, under such extreme conditions, then perhaps life is not rare at all. Perhaps we've simply been looking in the wrong way, or in the wrong places. If you enjoyed this journey, make sure to like the video and subscribe for more explorations like this. Because out there, beyond the stars we can see, there are still questions waiting to be answered. Until next time, stay curious.